Hello guys, welcome back to my channel. So we continue with the exercise 5.6 today, which is nothing but parametric differentiation. Okay. Till now what we have seen? Till now we have seen like basic continuity, differentiability, differentiation, how to do differentiation, first order differentiative, and after that we saw inverse trigonometric functions differentiation, and then we saw logarithms. I had uploaded a separate video on logarithms itself. After that, we learned to do logarithmic differentiation and exponential differentiation. Now we'll come to parametric differentiation. Okay, what is first of all parametric differentiation? So nothing. Okay, so if you want to differentiate a function y with respect to t, by chain rule you can do dy by dx first and then dx by dt. Okay, this is the chain rule, right? First with respect, we are differentiating with respect, if function y is a parameter of t, now both t and x, now we have to differentiate with respect to t. Okay, so what will you do? First you have to differentiate with respect to x, and then that x you will differentiate with respect to t. This is chain rule, right? So you can consider this dx get cancelled also, but that's not how it really works. So from this, what we can understand, dy by dx is equal to dy by dt divided by dx by dt, right? This is parametric differentiation. Okay, simple. They'll give you a function y equal to in sum of some function of t and x equal to some function of t. Okay, and then they'll ask you to find dy by dx. This is the whole concept of parameter. Why is it called parametric differentiation? They're introducing a new parameter called t, right? So that is the meaning of parametric differentiation. Okay, now we'll solve the exercise of this. We'll solve the questions on this exercise. So let me switch into the questions. Okay, first question, nothing but x equal to 280 square, y equal to 80 power 4. Okay. X equal to 280 square, y equal to 80 power 4. See, now they want you to find dy by dx. Okay, so now see, actually, if you see here, you can eliminate the parameter t, right? So for example, now this equation y equal to 80 power 4 can be written as y by a to the fourth root, right? This is equal to t nothing, and you can substitute this t in this equation, right? So you will get 2a y by a power 1 by 4 into 2, right? So this will be 2. So you will nothing but 2a into y by a power 2, right? So now you got x in terms of y itself, right? So you can directly differentiate the whole equation to get this. But this is not how we'll do, okay? This is a complicated method. Sometimes it can be complicated also. So maybe they'll mention in the question without eliminating the parameter. So what will you do? First find dx by dt. What is dx by dt? 280 square. Nothing but 2 into a into, these are all constants. What is t square differentiation? 2t. So it will be 4at. Similarly, do dy by dt. Nothing but a is constant, 4t power 3, right? So this will be 4at cube. Now dy by dx is nothing but, I told you the formula here, right? I'll write once here. You can first differentiate with respect to t and then divide that thing by differentiation of x with respect to t. So this will give you 4at power 3 divided by 4at. Okay, since this is the first question, I'm solving this very slowly. Okay, this will give you t square. So if you want, you can you can represent this in terms of x also. So from this, what you will get, t square is x by 2a, right? So x by 2a can also be written. Okay, see, it is very easy. It is done in 2 simple steps, right? So if you try to eliminate the parameter, it will be difficult. Okay, so that's why parametric differentiation is very important. Okay, Okay, so we'll move to the next question. Okay. Question number 2 is nothing but x equal to a cos theta. And this a cos theta, y equal to b cos theta. See, this is the same thing. Okay, you can like you can eliminate the parameter, but that's not the point of this. Okay, so I'll little bit increase the pace. This will be minus a sin theta. Dy by dt will be minus b sin theta because differentiation of cos is minus sin. So your dy by dx will be this divided by this. Sin theta gets cancelled. So it will be b by a. That's all. See, one line answers you're getting. Okay. Now, next question is x equal to sin t, y equal to cos 2t. X equal to sin t, y equal to cos 2t. Simple. X dash is nothing but I'll write x dash instead of writing dx by dt every time. So it'll be cos t. Now y dash is nothing but cos differentiation is what? Minus sin, right? Minus sin 2t times 2. Don't forget sin 2. Okay. So your dy by dx will be, see here y dash is nothing but dy by dt. Okay. So your dy by dx is nothing but minus 2 sin 2t divided by cos t. Now actually you can leave it like this, but can you see some like formulas of trigonometry where you can simplify this? This will be nothing but what is sin 2 theta? 2 sin theta cos theta, right? So this will be 2 sin t cos t divided by cos t. Cos t cancel. So it will be minus 4 sin t. Or can be written as minus 4x also. Understood? Very simple guys, okay? So we'll move on to the next question. Fourth one. X equal to 4t. See, this exercise, like there's nothing too complicated at all. Okay, just simple differentiation only. X equal to 4t, y equal to 4 by t. Okay. Now what is x dash 4? Y dash is nothing but what is 1 by t differentiation? Minus 1 by t square. So see, by this time we are the 6th exercise already. So you should know all these derivatives by heart. Okay, I'm not telling you to by heart as in like keep memorizing it or like that. By practicing questions, you should get a hold of it. Okay, so this will be minus 4 by t square. So your dy by dx will be minus 4 by t square into 4. So this will be 4 cancelled, minus 1 by t square. That's all. Okay. Or you can write as like t is in the x by 4, so x square by 16. So you can minus 16 by x square. You can write it like that also. Okay. Fifth question. X equal to cos theta minus cos 2 theta. Okay. Y equal to sin theta minus sin 2 theta. So what is x dash now? This will be minus sin theta minus minus 2 sin 2 theta. Understood? Why is something but cos theta minus 2 cos 2 theta. Understood? Why? Sin 2 theta's differentiation is cos 2 theta. 2 theta's differentiation is 2. Chain rule again. Same concept only. Okay. Nothing complicated. So this will be dy by dx will be cos theta minus 2 cos theta divided by minus sin theta plus 2 sin 2 theta. You can simplify this obviously. Like what is cos 2 theta, what is sin 2 theta? See, we know that You can't simplify this, I think. Like you can leave this as it is. I just check the solution. They also left it like this, so I think you can leave it. Okay. I mean, obviously, like your half angle, like your double angle formula won't be won't be useful here, right? So that is the reason I think. Okay.
So your next question is sine cube t divided by root of cos 2t y is equal to cos cube t divided by root of cos 2t. So as I told, right, this is also like much of trigonometric question only. We'll try to solve first dx by dt. Okay, so this will be u by v form, right? So this will be v du minus u dv by v square, the division rule. Okay, so this will be root of cos 2t v. Use differentiation is 3 sine square t times cos t minus sine cube t times root x is differentiation is 1 by 2 root cos 2t. Cos 2t's differentiation is minus sine 2t times 2. See, chain rule is very important. Okay, you have your v square here as cos 2t. Okay, v square. Now take LCM, guys. Okay, 2 cancels. Take LCM, you'll get cos 2t times 3 sine square t cos t plus this will be sine cube t times sine 2t divided by, you will get cos 2t, you will get, because you'll get root of cos 2t. Root of cos 2t and cos 2t combines to give, I'll write it here, cos 2t power 3 by 2. Understood? Okay. Now, so what all you can take common here? Sine square t cos t you can take. Inside it you will get 3 cos 2t plus, if you take sine 2t is nothing but 2 sine t cos t, right? So from here only you took cos outside. So your sine is still pending. One more sine is pending. So this will be sine square t. How? See, sine cube, from here you will get sine square, and from here you get cos. So remaining is 2 and sine, right? So 2 sine square t. Understood? Cos 2t power 3 by 2 is there. Now this will be sine square t cos t times. Now cos 2t can be written as 1 minus 2 sine square t, right? So be 2 sine square t divided by cos 2t power 3 by 2. Understood? This will be sine square t cos t times 3 minus 6 sine square t. So this will be 3 minus 6 sine square t plus 2 sine square t will be 4 sine square t divided by cos 2t power 3 by 2. Okay. So we'll leave here till this. Now we'll try to solve dy by dt. Okay. Same thing, guys. This will be again make u by v. What is y? Y is nothing but cos cube t by root of cos 2t, right? So this will be root of cos 2t times minus 3 cos t sin t. Sorry, cos square t sin t. How? 3 cos square t and cos differentiation is minus sign. So, okay. So minus, this will be cos cube t v du minus u dv. U dv is nothing but 1 by 2 root cos 2t times cos 2t's differentiation is minus sin 2t times 2. You have this cos 2t power 3 by 2 left. Okay. Cos 2t. First it will be cos 2t only. Okay. Now same thing you have to do here. Take LCM of cos, root of cos 2t. So this will be cos 2t times. Take minus here. 3 cos square t sin t minus will be plus, right? This will be 2 get cancelled. So this will be cos cube t times sin 2t. Understood? Now similarly take here cos square t sin t. Take common outside. You will get minus 3 cos 2t plus what will be remaining? Sin 2t is again 2 sin t cos t. Now cos cube, you have to take cos square outside. Sin is taken outside, so the remaining will be 2 cos square t. Understood? Same thing, c square times c, right? So c square you've taken outside. From here s you have taken outside, because here also you have c square cos square sin, right? So cos square sin you have taken outside. So you will remain with 2 cos square t, right? So you will have this cos 2t power 3 by 2. Same thing, cos 2t power 3 by 2. Okay. Now comes the simplification. Okay. Your dy by dx will be, you already have there, what do you have? This will be dy by dt by dx by dt, right? So this is dy by dt. From here cos square t sin t. So cos square t sin t times minus 3 cos 2t plus 2 cos square t, right? See, this cos 2t power 3 by 2 and same denominator get cancelled. Okay, divided by, here you will get sin square t cos t, right? Your multiplication will be 3 minus 4 sin square t. 3 minus 4 sin square t. So I left this simplification step here. This will be, you cancel, you will get cos t and sin cos t divided by sin t. Okay. If you use the simplification here also, it's minus 3 of same thing. This will be 2 cos square t minus 1. Cos 2 theta is 1 minus 2 sin square theta, or 2 cos square theta minus 1. This will be 2 cos square t divided by, you will have 3 minus 4 sin square t also. Okay. See, the question is a bit lengthy only. You should solve it now. This will be cot t. Okay. Cot t is there. Minus 6 plus 3, right? Minus 6 plus 2 is minus 4. Minus 4 cos square t. Correct? Minus 4 cos square t plus 3. Right? Divided by 3 minus 4 sin square t. See, now comes the thing. If you don't keep here cot t, okay, just try keeping cos t by sin t. Okay. Now multiply inside this. So what will get? 3 cos t minus 4 cos cube t divided by 3 sin t minus 4 sin cube t. This will be nothing but cos 3t. This will be nothing but sin 3t. Okay. Understood? So this will be cot 3t. Simple, guys. Okay. The calculus part was very simple, right? The trigonometry is a little lengthier. Okay. So we'll move to next question. And next question will be 8th one, right? Question is 8 something, but x equal to a of cos t plus log tan t by 2. We don't get like don't be afraid of the complex function at all. Okay. Only thing you need to know, like 3-4 things: differentiation, chain rule, u by v, u v. That's the main thing. Okay. So this x dash will be nothing but a will be kept as, this will be minus sin t plus 1 by tan t by 2. Why? Because tan log x differentiation is 1 by x. Now tan t by 2 is nothing but secant square t by 2. Tan differentiation is secant square. And again 1 by 2 is there. Okay. Now your y dash will be a cos t. Understood? So x dash will be a of minus sin t plus 1 by tan t by 2 is cot t by 2. So you can write that as cos t by 2 by sin t by 2. Secant square t by 2 can be written as 1 by cos square t by 2 times 1 by 2 is there. Okay. So this will be nothing but a of, yes, cos square will get cancelled. So minus sin t plus 1 by cos t by 2 sin t by 2. Okay. Now you have 1 now. So 1 by 2 is also there. Now 2 cos t by 2 sin t by 2. This will be nothing but sin t, just sin t. How? Sin 2t formula is there, right? You will write that as 2 sin t cos t. So sin t can be written as 2 sin t by 2 cos t by 2. So you will get a of minus sin t plus 1 by sin t. So it will be nothing but a of 1 minus sin square t by sin t. So this will be a of cos square t divided by sin t. What do you have in y already? A sin t. Differentiation is a cos t, right? So your dy by dx will be a cos t is there divided by a cos square t times sin t. Will get cancelled. A get cancelled. So sin t by cos t will remain. So this will be tan t directly. Understood? Very easy only. Okay. So there are 2 questions left. See, this one is pretty simple. 10th one is pretty simple. Okay, you can solve this. Just try. 11th one is also simple only. It just involves sine inverse differentiation, right? So there will be root of a power sine inverse t, right? So what is root x differentiation? What is a power x differentiation? What is sine inverse differentiation? All these things you should know, because you should use chain rule, right? So you can try these 2 questions. Oh, I left one 9th question. So this is also simple. A secant theta, B tan theta, right? This will be very simple. A secant theta. A secant theta's differentiation is, I'm not able to write here. Okay. So A secant differentiation is secant theta and tan theta. Now this will be secant square. Secant we cancel. It's very easy, guys. Okay, you can do 10 and 11 also. You can do same thing. Okay. So next one is like second order derivative that we'll cover in the next video. I think that's all. The chapter is getting over, and then we have one miscellaneous exercise alone. So yeah, we'll try to finish up this, and we'll go to application of derivatives. Okay. Thank you, guys. Thanks for watching. Bye.